Hey everyone, so now that we're done with circles, our last unit is area, surface area, volume, all stuff like that with polygons. So today we're going to do just basic area of like all different shapes. So it should be pretty easy, especially since you have formulas. You'll see here, let me get rid of this. You'll see here that I posted this formula sheet for you to use. Um, they're pretty self-explanatory, but I'll just go over a couple things first. So anytime an area formula talks about height, so like for a parallelogram or a trapezoid, the height always has to be perpendicular to the base. Like same thing here. It's kind of hard to see, but this is a right angle. Same thing here. This is a right angle. So heights and bases are always perpendicular. So you might want to add that in somewhere. Heights are always perpendicular to the base. So if you are not given, say, the height, sometimes you have to find it. So you'll see in some of the examples, I'm going to do one or two examples where you have to find the height, like you're given a side, but it's not the height because it's not perpendicular. So when you're using a height in your formula, it has to be perpendicular. So parallelogram is pretty easy. It's just base times height. Trapezoid, you take the height and then you multiply it by the sum of the bases. So base 1 and base 2. You add those together, multiply by the height, and then divide that by 2. So there's for a trapezoid. A triangle, I think we've done before, but it's base times height divided by 2. Or another way, I usually teach it as 1/2 times base times height. But same thing. Rectangles, length times width. Circles, we've done circumference before at the beginning of circles, but we never really talked about area. Area is pi r squared. And then a sector. A sector, we actually haven't even learned about. So this is a sector. It's basically just like a piece of a circle, like a piece of pie or like a piece of pizza, something like that. It's a section. So this point here is at the center of the circle. So this is the formula right here. Arc length, we already learned that earlier. This is the one we're going to use now. Area of a sector. You take the measure of the angle. So in this case, M stands for the measure here of the angle. So it's the measure of the angle over 360 and then times the area. Remember, like this part is going to tell you like what percentage of the circle it takes up, and then you're multiplying that by the area of the circle. And then a rhombus and a kite both have the same formula. It has to do with the diagonals. So you multiply it's 1/2 times the diagonals multiplied. Or I guess you could think of it as D1 times D2 over 2, same thing. Okay, so I picked a couple problems from the practice that I uploaded that I'm going to do with you, so you have a few examples done out. Okay, so on the first page, you have to do these 4, but I'm going to do number 2 for you. So number 2 and number 4 are kind of done the same way, where notice these are parallelograms, and so it's base times height. That's the base, this is the height. Notice we're not given the height here, so you have to find it. So you have to use special right triangle rules. So you could, well, just because this one is a special right triangle, but if it wasn't, like say, well, these are both special right triangles. So if I had given you one where maybe this was like 62, you would have to use SOHCAHTOA, which you could use SOHCAHTOA here. I bet a lot of you probably prefer that. So this is the height, which that's opposite, and that's hypotenuse. So you could either do, oops, that's height, yeah, the opposite. Here we go. Sorry, I was getting confused by that. So anyway, you could do sine of 60 equals h, which is standing for height right now. I should have just used x so it's not confusing, over the hypotenuse, which is 4, and then you would solve. Or you could think about special right triangle rules where this is the hypotenuse, so this is 2 and this is 2 radical 3. It doesn't really matter, but then you would just multiply. So the height is 2 radical 3. The base is 5.5. So the area, 2 radical 3 times 5.5. Just remember too, when you are doing area, your units always have to be square units. Okay, so this turns out to be approximately 19.05, and that would be feet squared, or you can write square feet. Either way, just make sure you remember to label your units. So that's how you would do number 2. Number 4 would actually be done in a very similar way. You have to find this height and then do base times height. The others are pretty self-explanatory. Number 8, this is the triangle that you're trying to find. So this is your base, this is your height. I honestly don't know the purpose of that triangle, why that's there. But I think they want you to find that one. Okay, so that's the first page. The second page, I don't really think there's anything that I need to go over. It's pretty self-explanatory. The third page with circles, I'll do a couple of these. So this first one, you just find the area. So that's pretty easy. They give you the diameter, so you have to find the radius and plug in. 4 and 6, I'll do one of these. I'll do number 4. They give you the area and you have to work backwards to find the radius. I'm sure most of you could probably figure out how to do it, but I'll still do it for you. So I'm going to do number 4, then you guys can do 6. So the area is 132.7, and that's equal to pi r squared. So then you have to just solve for r. So you're going to divide by pi. So 132.7 divided by pi is 42.24 equals r squared, and then you're going to take the square root of both sides, which is 6.499, so we'll just go with 6.5. And then they asked us to find the diameter. So if they asked us to find the radius, we would be done now, but you have to multiply by 2 to get the diameter, which would be 13, and that's centimeters. So number 6 is done in a very similar way. I'm going to do one of the sector ones. So 8, 10, and 11 are all sector problems. So I'll do one of these for you. I'll do number 8. So remember, on the formula sheet, the area of the sector is the angle measure. Oh, it says shaded region. I think this is supposed to be shaded. So it's the angle measure. So 51 over 360 times the area. So times pi times 2 squared, which is 4. So, which I'll write over here on top, 2 squared, so you know where I'm getting the 4 from. So 51 divided by 360 is 0.1416 repeating, and then I'll just do times 4 pi. So this area of this sector is approximately 1.78 meters squared. And then 10 and 11 are done the same way. Okay, so that's the basic area. The last page is something called composite figures, where it's just like a few different figures like together. So I'll do a couple of these. So basically what you want to do here is separate the figure into shapes that you know. So this first one here, like if I like dropped a line right here, this is half a circle, and then this empty space is half a circle too. Notice this is a square. So basically you could do the square plus the half a circle minus the half a circle, which will just cancel out. So this one you really just need the square, but I'll write it out anyway. So square plus the semicircle, but then we're subtracting the same semicircle, so it just turns out to just be the square. So you would just do 20 times 20 for that one. That one's pretty easy, which is 400. And it's millimeters squared. Okay, so there's that one. This one here, you would split it here. This is a semicircle with a diameter of 9, so a radius of 4.5. And then this is a trapezoid, so you would just do the semicircle plus the trapezoid. A semicircle, I'm sure you probably figured out, you just do the area of a circle and then divide by 2. That's all. So I don't really think I need to do that one. Like number 6, you would split into like here and here. Why don't I do this one out so you have another one completely done out? So sometimes I like to like number the parts 1, 2, and 3. So that way when I do out my work, it's nice and organized. So section 1 is just a square. So it's 13 times 13, which is 169. Section 2 is a trapezoid. So the bases are 13 and 30. So 13 plus 30, you add the bases, multiply by the height, which is 20, and then divide by 2. So 13 plus 30 is 43 times the height, which is 20, divided by 2. So section 2 would be 430. And then the third one is a semicircle with a diameter of 30. So the radius is 15. So it's going to be pi times 15 squared. And then we have to cut it in half because it's a semicircle. It's not a full circle. So 15 squared is 225. So 225 times pi and then divided by 2. So this one's going to be about 353.43. And then lastly, you have to add them all together. So 353.43 plus 430 plus 169. The total area for number 6 would be 952.43 square inches. So that's how you would do one like that. The rest are pretty self-explanatory, I think. I mean, this one would be cut into a rectangle and a triangle, which you do have to identify this height because remember your base and your height are perpendicular. Same thing here. This one is a semicircle and then again a triangle, which they gave you the height for. Down here for number 7 is a square, and then you're taking away the semicircle. And then this one, we have a rectangle, and then it ends up being a full circle because you have your 2 semicircles. So, I mean, I think you guys should probably be able to figure the rest out. I think that's enough for me to do out for you. If you are stuck, feel free to just come to office hours at 11:30. All right, that's it, guys. Have a great day.